several factors. One is that a big question that my research group is interested in is trying to see how we can ensure that when someone pays for a service, that the person who purchased the service receives that service. So can we help ensure some sort of matching between the buyer and the consumer? So how can we use spatial tools for that? And then the second part ties to some of the social questions we were talking about yesterday. And part of that is how do you decide who to pay? And one of the questions that my team likes to explore is whether you can almost take that out of the picture by focusing primarily on which portion of the landscape provide the service. So selection as to whom to pay isn't made based on social criteria, but it's made on, again, trying to ensure that there's this link between provision and reception or consumer and producer of the services. So we'll talk a little bit about that also. In this example, there's a couple examples that I wanted to give. Well, in this talk, a couple examples I wanted to give. The first one is work with Wilfredo Chavez, who was with Cartier, and then Ryan Niemeyer, who was at the University of Idaho, looking at the riparian services as part of the Funky Tree project that Graciela also co-manages. And in this image, what we don't see very well is the landscape in Nicaragua, where it's dominated by pastures. Is this focused, or is it just a light quality issue? So you can see that you have a landscape dominated by pastures and these very dominant riparian forests that remain retained in the landscape. And so these really, in this particular landscape, are some of the last relictual remnants of these forests, and our conservation priority, because they're ecotonal, because it's interface between terrestrial and aquatic systems, because they're linear or dendritic and provide an element of connectivity in the landscape, and because they provide, I think, some very important socio-ecological services tied to water quality. Wilfredo Chavez, who is right here, from Peru, began by working at the Rio Gil Gonzalez watershed, Nicaragua. Lake Nicaragua is right here. You can see the shoreline, and you can see the forest showing up as red, the pastures showing up as green. And what Wilfredo wanted us to do is see if you can identify forest quality in remote sensing, which is another important policy mix issue. Can we go beyond just forest and non-forest, or even different forest types, but can we identify the quality of the forest and then direct payments based on that kind of classification, either trying to improve forest quality where you can improve it, or conserve it where the quality is high. So this is the map that Wilfredo developed, and he identifies five functional types of forest that are largely related to forest quality. And so you see the riparian forest identified here, with each pixel, 30 by 30 meters, identifying the different types. And you can see that within the riparian forest, you have some that are high quality, type 5, and other patches that are low quality, type 1. So we now have the spatial map developed from remote sensing that suggests that we're able to differentiate between forest types. Here's just zooming in. And this is what these different types look like. So we go on the ground and try to validate this classification. What we find is that the type 1 forest are these heavily degraded forest types, very low tree density, a lot of patches in the landscape. Type 2, again, very low density forests, small diameter trees, wide distribution between trees. Type 3, starting to look more like a secondary forest. Type 4, increasing structural complexity in that forest, and then type 5, which is the representative of the most intact forest type within this landscape. So a high distribution of stem diameters, several very large stature trees, multi-strata system, often missing this herbaceous system. And then we go on the ground to try to measure some of this. We find that our classification ties very nicely with important characteristics of forest quality. Here, Wilfredo has it scaled backwards. So it goes from the high quality forest type 5 to low quality forest type 1. And you can see that there's a very strong change in basal area as you go from intact forest to degraded forest. There's a pattern also of a change in height, so very well-established forests with the well-developed trees going down to very low-statured shrubby type forests. The distance between the trees is quite low in the more mature forest or intact forest, and then very high between trees, so lower tree density. Shrub cover is the opposite. Very high shrub cover. High shrub cover in the mature forest, goes down to the intact forest, but the opposite with the herbaceous layer. So you're shading out this herbaceous layer with these mature forests. And then finally, the leaf area index being the rainy season. So how many layers of canopy you have in these forests being quite high in the more mature intact forests and being very low in these degraded forests. So using remote sensing, we're able to identify, if you want, these fairly basic elements of forest quality. And of course, what we're interested in is in ecosystem services. And so what we then tried to do with work that Ryan Niemeyer provided was to look at the infiltration rate, which is KFS, and see whether there's correlations between forest quality and these infiltration rates. Being that this project was funded by Funky Tree, we wanted to look at tree functional diversity to see if there's a relationship between species richness, somewhat of a relationship, but stronger relationship with base layers. So again, the higher the density of the trees within the forest, the larger section of the trees, a greater amount of infiltration rates in those forests. We can tie this then to the different functional types, or the different 5 types that we've identified. Here's Ryan Niemeyer from the University of Idaho with his saturated hydrometer, measuring filtration rates, and we find a very high relationship between the capacity of these land uses to absorb water on the site. So this is basically, a tube that is put into the ground, and you measure how quickly the soil is able to absorb water. So there appears to be a very strong relationship between forest type, forest quality, and the ability of that forest then to absorb water that's either received on site or coming from adjacent pastures. And so what we suggest then in the context of a payment services programs is that we have 3 forest types where there's no service being provided, and then at least 1 forest type where there is a service being provided. And that this kind of information can then be used within payment services scheme to identify differentiated payment types. So one, with these type 1, type 2, and type 3 forests, there we'd probably be more interested in payment for restoration. And so we should consider, well, does that mean that we need to include funding that will pay for the intervention, differentiate from payments for conservation, type 5 and type 4 forests, where there maybe the payment would be less because there isn't this upfront investment in restoration that might be needed. The other advantage, again, being is that with this kind of a system, you can actually identify individual landowners or property owners that have the different forest types. And rather than have a system where they come to an agency that's making the payments and request a payment, the agency that's interested in the service or the purchaser of the service can go to the landowner saying, we're interested in purchasing the service that you're providing, and we can negotiate a payment.
Just very quick, can you say exactly what the service is? Is it a runoff regulation or is it water balance?
It's a water quality. So it's improving the water quality of the riparian system, and then with impacts in Lake Nicaragua. There's a sugar refinery located in the lower portion of the watershed that is the primary agent that's interested in making those payments as an offset for some of their environmental damage.
That was my question as well. Is this an ongoing small-scale PES, isn't it?
Yeah.
So that's why also it may be possible to go and target specific people.
Yeah.
Very,
yeah, and I'd like to address that in the last couple of slides also. So let's skip this. So within the Turrialba corridor, we have one biological corridor that's a socio-ecological construct rather than a purely conservation biology type system. We're not talking about the corridors that conservation biologists talk about, these linear forest elements crossing landscapes. but we're really talking about a mixed land use, a mosaic that is being managed by a collective group of stakeholders to try to ensure connectivity between these large protected areas. And I think that what's interesting is that when you go to these stakeholder meetings, we're not talking about connectivity, but we're talking about hydrological services. And so within the Costa Rican context, what you see is that the corridors are structured around this notion of mixing of services. And so there's this, I think, this very fundamental question. When we manage these landscape mixing of services, do we get the conservation benefits of that we're interested in? Now in Costa Rica, with Conapipo, we're paying for scenic value, carbon, biodiversity, and water. The way that there's a very national level type of payment where we might prioritize within biological corridors or other conservation areas, identified at a very core scale. We talked about gruas yesterday. But there's also some very specific services that are in demand. The Reventazón River, which is 200 meters behind us here, currently produces 2,400 gigawatts of the 9,400 consumed in Costa Rica, 25%. And with the construction of the Reventazón dam, a third dam being put in place, it'll be producing 4,500 in 2014, or nearly 40% of the national consumption. So water quality is really a critical system of services within this biological corridor. Here's the three dams: the Cachi Dam, the Angostura, which is 1 kilometer up the road, and the Reventazón Dam, which is currently being built on top of several other hydroelectric stations that are in between those dams. One of the main costs in operating these dams is sediment. So sediment in terms of its impact on the turbines, sediment in terms of its impact on the water storage capacity of the reservoirs. If you have sediment, that's volume, it's occupied by soil rather than by water, so that affects your capacity to produce energy. And also the role of these ecosystems in the waters in terms of regulating the flow of water. Is it large pulses, or do we find that the different land uses then serve as a means of regulating the flow of water, so evening it out over the course of time? And so there with Natalia, we propose that if this is a service that ISE is really interested in, that we really should be focusing again towards these targeting. Here's the Natalia over here. And can we then use these ecological models such as RUSLI to identify what are the priority or the critical areas in terms of soil provisioning, and can we then target our payments within these portions of the water to ensure that when ISE pays for sediment control, it actually gets sediment control that it's looking for. And argue that if you're going to differentiate a payment, that you should then probably pay more in those areas that are critical than pay less in the other areas. And this can help ensure that for every dollar you invest in sediment control, you get that equivalent amount in sediment reduction. The other primary goal of the Baja corridor, of course, is about connectivity. So again, here, not all portions of the landscapes are equal. You know, a farm that's located in a sea of sugarcane isn't going to make a significant contribution to biodiversity conservation. Whereas a farm that's located between two forest patches, I think has much more potential in terms of